Dear students, how are you all? Hopefully you are well. Today we are going to discuss about chapter 13 on your higher mathematics, and this is on your solid geometry part. Actually this is the part where we are discussing about the properties of solid and the surfaces, lines and the points. Actually this is also called, or the solid geometry also known as the geometry of space or three dimension. Actually today we are going to discuss about the basic thinking or basic concept of the solid geometry, and it is also very much important for your MCQ too. So it's very possible, if it is possible to take it as basic as well as MCQ, it will be very much helpful for you. Okay, today here the chapter 3 are talking about the solid geometry, what I have been just said, and this solid geometry are also known as geometry of space or three dimension or geometry of three dimension. Every two name are very much familiar or very much synonym for the solid geometry. Okay, now we are discussing about the dimensions. What actually the dimensions and why we are talking about the dimensions in these sections, because solid geometry is a geometry where you have to think about the dimensions. Here we know that there is different types of dimensions, 1D, 2D or 3D. It is very much useful name for, or it is very familiar name for us. So here dimensions, the definition of dimensions says that if each of the length, breadth and height, what I have been telling it, that each of the length, breadth and height of a body is called the dimension. So if there is a length, then it is only length, no breadth and height, then it will be 1D or one dimension. If there is length and breadth both but not height, on that time we can say it is the two dimensional. And if there is length, height and breadth, all three are present there, then we can say on that surface or on that body is known as the three dimensional body. Okay, now there is some examples to understand the dimensions. That's why I am first take the name as point. What actually the point is? I have written here that point has no dimensions. Why? Because if we see the figure of point, it looks like this. This is a point. In this point there is no length, no height or no breadth. So it is just a position, and actually this is not positional positions also. This is called actually the positions, where it has only the position but no length, breadth or height. That's why it is called as no dimensions. Okay, now line. What is the figure of the line? The figure of the line is like this. In this line actually it has only the length, but there is no breadth or height. That's why we can say this is the 1D substance. Here the surface generally looks like this. On that surface we are seeing that here the length and the breadth, both length and breadth are present. That's why it can be said as it is the two-dimensional body, and the example of two-dimensional body is called the surface. Here I wanted to talk about different type of surface too. Actually surface can be the plane surface, and there is another surface that is called the curved surface. What actually the plane surface or curved surface is actually, if we relate in our practical life, this is the board. We may think that this board are, if we are thinking this the plane of this surface, then this is the breadth and this is the height, this is the length and this is the breadth. If we are thinking just these two part, not the total board, actually just the plane of the board or the surface of the board, on the time this board can be talking as well, or can be assumptions. If we are thinking that this is the board and this surface are actually the plane surface, this surface are actually the plane surface. Or if we are thinking that the pond, the still water pond, generally we are seeing that on that water can be talking about the plane surface. But if we are thinking the circular thinking. It can be looks like ball, or it can be a ball. On that ball, we know the ball of the surface of the ball, that is the radius. On that time, we can say that is the curve, or the surface of the ball is a curved surface. Okay. Now we are talking about the cube cube. In that cube, what is actually the figure of the cube? The figure of the cube can be looks like this. The figure of the cube generally looks like this, where all length, breadth and height, every three parts are available in there. That's why it is called as 3D. These are known as the three-dimensional part, or 3D, or three-dimensional surface. If we are thinking the whole board, on that board what we are seeing here, so look at the board here. This is the part what we are talking about. This is the length, this is the breadth, but what about this? Here is some height of the board, or the thickness of the board. So here three particles are there. That's why our total board can be think about that this is the three-dimensional part. Or as a if we are talking about a book, you are thinking the book of the, or suppose this is the calculator. In this calculator, you are thinking that this is the length, this is the breadth, and this is the thickness of this. Can be talking about the height. So this is the concept of three-dimensional. Okay. So now we are talking about some formulas. In the solid geometry part, we are trying to see some types of formula, or some types of shapes we will get, and we need to know how the shapes looks like, or what is the formula to find out the shape. Suppose in this solid geometry part, we have to deal with rectangular parallelepiped, or cube, or pyramid, or prism. There will be some circular part, cones, or cylinder. So different types of shape we will get. On the time, we need to know actually how we can find the shape, or how we can find those shape of area. That's why we need to know some formulas. Here we need to know the formula of the rectangular parallelepiped. What actually looks like a rectangular parallelepiped? It can be looks like this. Suppose this is a rectangular parallelepiped. In this rectangular parallelepiped, there we will find three parts, or three properties. One is its length, and there is a breadth, and there is also a height. If we are considering our length as L, and our breadth as B, and our height as C, then we can talk about the formula of the area of the surface. The area of the whole part will be 2 into AB, that is length into breadth, plus BC, that is breadth into height, plus CA, that is the height into length. So this is the formula to find the area of the surface. And how can we find the volume of that surface? The volume will be just the multiplication of area, length, breadth and height, that is A into B into C. So this is the way we can find the volume of that part. Now we need to know how we can find a diagonal of this part. Generally these diagonals can be understood by you very easily. That's why I wanted to see you or show you a rectangle. If it is a rectangle and there is two part, that is length and breadth, then what will be its diagonal? Its diagonal must be this part. And when we are talking about this part, we always try to find this length by using Pythagoras formula. And if we are using Pythagoras formula, then we can get root over a square plus b square, isn't it? If this is length, this is breadth. So since here is three components, that is length, breadth and height, that's why the diagonal will be looks like this, and here three components will be coming. On the time we will get actually root over a square plus b square plus c square. This is the way to find the rectangular parallelepiped diagonal. And now we are talking about the cube. How we can find the area of the cube? The area of the cube can be found as actually what actually the similar part of the cube and rectangle. We need to know that in this cube part actually here we are seeing the three components, that one is length, breadth and height. But in the cube part actually all the length, breadth and the height would be same. So the length, height and breadth would be same. On the time you can say A is equals to B is equals to C. All are actually equal. If all are equal, then the area of the surface will be 6a square, area of the volume will be a cube and area of the diagonal will be root 3 into a. Maybe one question arises in your mind, why we are talking about this is 6a square or how it comes, isn't it? If your question looks like, then just putting the value of a at the place of b and c. Suppose in this part 2 into a plus a into a plus a into a. So from here we can write 2 into a square plus a square plus a square. So it is 2 into 3a square, that is 6a square. Okay, so 6a square will be our area of surface. And similarly, if we are putting the value of b and c, here a and a, then a cube, and here also a square plus a square plus a square, that is root over 3 into a square. So root 3 into a, because square and root will be gone. So this is how we can find the formulas of the cube. But it is also very important to know the formula of the area, volume and diagonal of cube too. Okay, now we are discussing about two parts. One is prism and other one is pyramid. In these two topics, generally you are very much worried about this, but I wanted to make you clear what actually the pyramid and what actually the prism and how to solve these types of math also. Okay, first of all, what actually the prism is. Here is a definition what can be found by our book or the textbook, that is a prism is a polyhedron. This is the number 1. 2 is bounded by two parallel polygonal face, and other faces are always being the parallelogram. What actually talking about these three parts? Actually, if we are talking about the definition, if we are trying to give the definition of prism, it looks like this, that here we will see two base. On that two base will be the identical, or the two sides of the prism will be the identical. Generally what we are talking about, or what looks which types of prism generally we found, it maybe looks like this, maybe looks like this. Okay, maybe looks like this. Suppose here is a triangle and here is also a triangle. This actually this is a triangle, and these types of triangle can be found here. So this is the base part, we can say this is the base part. Or if we are trying to take this position is vertically, this is the horizontal part. If we are trying to take it vertically, then we can see that this part and this part, or that this triangular face and this triangular face are equal. First of all, there is no rules that all of the part or all of the base must be same. Here the base is this, actually base is this is also the base. This base can be the polygon. So there is not hard and right rules that it must be a triangle. It can be a polygon, that is triangle, quadrilateral, pentagon, hexagon, anything else. Okay, we are trying to draw a pentagon actually. Pentagon. We are trying to draw a pentagon actually. It can be like pentagon. So 1, 2, 3, 4, 5. Okay, this is a pentagon, and here we will see a same pentagon in here. If we are trying to add this, okay, if we are trying to add this, then we may think that the replica of this part is here. The replica of this part is here. So this is looks like this part. Here is a surface and here is the other surface. This can be talking about base and this can be talking about the top. Or we are thinking that this is the base. This is the basement, or this is the base part, and the other part and the actually the inner part of this generally called as the lateral part. Okay. So the volume of this prism, is talking about the area of base into height. Just we need to find the area of base. Why we are talking about area of base? Because we don't know which types of polygon we will take. If we are taking the base as triangle, then we have to find the area of the triangle. If we are trying to find the pentagon like this, or hexagon or octagon, anything else, so we will find those polygons area. That's why we are talking about the volume will be area of base into height, and the lateral side area it will be, actually this is called lateral surface area. This lateral surface area will be the perimeter of base into height. The perimeter of base, we have to find the perimeter of base into height, and the total surface area will be the lateral surface area plus 2 into area of base. Here again one question in your mind, that why you are going for 2? Because here is 2 base. Here is 2 base. That's why you have to multiply here by 2. Okay. Now what actually the basic difference I wanted to show, that is the pyramid. In this pyramid there will be one surface. That surface will be looks like, actually we are talking about the same pentagon also. This is the pentagon, and here there will be a point. Here there will be a point, not the same pentagon will here. If we are talking about prism, then we also need a actually pentagon looks like this, but at the case of pyramid we need only a point, and here will be a base, and this base is a polygon, and we are taking a pentagon as polygon. In this pentagon there is 5 vertex, and we have to just add all the vertex with this point. If we are adding, then we get a pyramid. So how? Suppose this is one part, second part, third part, fourth part, and fifth part. So here all the vertices have been added with the point. So we can say this figure is a pyramid, and in this pyramid we can find the volume of the pyramid and the lateral surface area and also the total surface area. How? Here the volume will be 1/3 into area of the base into salient height. One thing arises in your mind, what is the salient height? And the salient height is this is one types of height. Here actually just think about that. Here is a surface, here and there is a pentagon, and there is a point. This point actually added all the vertex. So all the vertex, since it is added, so all of the height will be looks like this, not the directly the perpendicular. It is just a it's just obtuse actually the surface. That's why we will take a point in the middle, then just add this, then we will get a height. We will get a height, and this height is generally known as the salient height. Okay, when you are trying to solve these types of math, then you can understand very easily that what actually the salient height is. Now the lateral surface area will be half into perimeter of the base into salient height. Why half? Here was not the half, but here is half, because here is only one, only one base, and here the total surface area will be lateral surface area plus area of the base. There is the absence. We are taking thinking that 2 is not here. Why there is no 2? Because here is only one base. That's why. Okay, so this is the total discussion of prism and pyramid. Okay, so this is the last part for our formula. So mind it, my dear students, we need to memorize this formula, all of the formulas, because all these formulas are very important for our MCQ part 2. Okay, so now we are first here the topic is the right circular cone. Actually what actually the cone looks like, we there is a taboo or the taboo. Actually these types of taboo are known as the cone, these are known as the cone, and these are called as the right circular cone, because if there is a right angle triangle, if this right angle triangle can be rotated like this way, then these types of cone are created. Okay, so the area of the surface, actually the previous part we have seen that always we are finding the area, but these types of part we need to find the area of first the circular part, then area of the total part. So here the area of curved surface or area of circular part is pi RL, and area of whole surface is pi r into r plus h. There is two part, one is this and other is this part. So area of these two part, if we are adding, then it is come pi r into r plus n, and volume is 1/3 into pi r square h. My dear student, no need to be worried, because when we are trying to solve these types of math, then again I will explain all of this. Okay, so first thing is we need to know the formula for our basic part or the MCQ part. I have this pair also. What actually, how a sphere can be a circle, actually sphere can be a circle. So in this circle we know the area of the circle is the area of the surface is, actually this is the surface. We need to find out the surface, not the circular area. Okay, area of the surface is 4 pi r square, and the volume is 4/3 pi r cube. And finally the right circular cylinder, we know the cylinder is, generally cylinders looks like this. Cylinders looks like this. Here two circular part is there. Actually this is not correct, the drawing is not appropriate. Actually the same types of cylinder will be here and here. That's why in this cylinder part we need to find the area of the curved surface. Area of the curved surface will be 2 pi r h. So the area of the curved surface is 2 pi r h, and the area of total cylinder will be the full cylinder will be 2 pi r into r plus h, 2 pi r into r plus h, and the volume will be pi r square h. So here we need to find actually what actually r and h. Don't worry, actually r is the radius of the circular part, and h, that is the height, actually height of the cylinder. Okay, here also the r actually the radius, you know, that's why I just skip that part. And here actually you know also r and h. R is the radius, h is the height, and l is the you know the height, it is the salient height, and this salient height can be known as the L. Okay, so this is all for our today's discussion, or actually the MCQ part. Okay dear students, now we are going to our math solution part. In this math solution part we are trying to show you some problems. Now our first problem is number 7, that is talking about the length, breadth and height, these three parts. What actually length, breadth and height of a rectangular parallelepiped are respectively 16 meter, 12 meter and 4.5 meter. What actually given? The length is given, breadth is given, and the height is given. We need to find the area, volume and diagonal. Is it possible by us to find? I think it is very much possible, because we already know the formula to find the area and volume, and also as well as the diagonal. So here actually given, we may think is at let our height, okay, let our length our length be A, that is 16 meter, breadth is B, that is 12 meter, and the height BC, that is 4.5 meter. These are actually given, but we are just assume that this is A, this is the value of B, and this is the value of C. Now we need to find the area. We know area of this surface is equals to 2 into AB plus BC plus CA. Just putting the value of A, B and C is 16 into 12, 12 into 4.5 and 4.5 into 16. If we are multiplying this, all of this, then we are probably get a value that is 318, and finally we get, actually if we multiply these two, then it is 636 meter, so meter square. Since this is the area, so our unit will be meter square. So this is the answer number 1. So this is the area. Now we have to find the volume and diagonal. So again we know the volume will be A, B into C, that is 16 into 12 into 4.5, because 16, 12 and 4.5 all are given. Just multiply these three. What will be there? The answer will be 864 meter cube. So this is the another answer. So we already get first answer, then our second answer, and third answer is the diagonal, and finally I think it will be LY. Okay, finally the diagonal equal to root over A square plus B square plus C square, that is 16 square plus 12 square plus 4.5 square. 16 square plus 12 square plus 4.5 square. If we are going to calculate this, then we are probably get 420 into 25, 420.25, and if we are rooting this 2, then it will be 20.5. So this is the answer number 3. Here this is our second math. Our second math says a rectangular tank of length is this, breadth is this, stands on the ground. If its height is this, then it will find you need to find volume and area. It's the very easiest one also. What actually here given the length, breadth and the height. Just find the volume and the interior area or area, those are same. Okay, so similarly let us assume that our A is 2.5 meter, B is 1 meter and C is 0.4 meter, and we know the area of the volume is, the volume of the surface is A, B and C. Just multiply these three, it will be 2.5 into 1 into 0.4. So it is close to 1 actually. If we are multiplying this, then it will be 1 cubic meter. Okay, and now again the surface area is 2 into AB, BC, CA. 2 into AB, that is 2.5 into 1 into 0.4 and 0.4 into 2.5. If we are multiplying all of this and multiply with 2, then we get very much close to 7.8 meter square. So this is an answer and this is the other answer. I think it is very much easier for you. Just putting the value of A, B, C at the formula, then we will get our total answer. So that's all our today's lecture, and after long Eid vacations, so This was your first higher math lecture. Hopefully all of you are well and try to remain well. Thank you very much.